Yeah, I sent them both invites as well to speak, but they're not coming up. Um, and I think everybody else, we're not taking requests on this one, so it's just going to be the three invited speakers. So I wouldn't really bother requesting to speak. You're just kind of cluttering the space. So, Emin, we've issued you an invite to speak. I think you have to accept the invite, and same goes for Anatoly. We did invite him as well, although I don't see him at the moment. Maybe he went off and is coming back on. Oh, there he is. Invitation sent to Anatoly. Hopefully he can join us. Who do you call for support on Twitter Spaces?
Yeah, I'm trying as well, but it doesn't seem like they're
Yeah, they're
receiving the
popping
invite
up.
for some reason. Yeah.
The drastic move would be to shut the room down and restart it, which would cost us a lot of people and recording. But I mean, and Anatoly, why don't you guys try leaving and coming back, and then we'll invite you again? I know that's suboptimal, but
No button to summon Jack to help everyone.
yeah. Oh, Jack is gone now, right? Anyway. Jack's a Bitcoin maximalist. He would probably show up and burn the room down.
Okay, looks like Anatoly made it. Now we're just
Yay.
waiting on Goon.
I saw Gun flash by with what is that, a Dracula NFT he's got? There he is. Come on, Gun. Your blockchain's got to be faster than this.
I think I made it. Can you guys hear me?
Yes, we can hear
Yes,
you loud and
we
clear.
have you.
Awesome.
Perfect.
All right, we just got the just need to get Avalanche on stage, but it seems like Twitter Spaces is not being
I
friendly.
switched to the mobile app. I was trying to do this on the Chrome website. So
Oh yeah. Gun, that may be an issue if you've got if you've got an iPhone or Android. That's probably the way to go.
Goon, if you haven't already, I'd recommend maybe leaving and coming back. So maybe while Goon is trying to get on stage, we can go ahead and kick things off.
Hi guys, I'm also on the mobile app now.
You
Here
made
he
it.
is. Yay.
Excellent. Okay, then let's get things started. So I'm going to first start giving some intros, and then Naval will give some background, and then we'll jump into questions. So obviously we've assembled here today three of the biggest creators of the largest emerging layer ones in public blockchains. First, we got Anatoly. Anatoly is the co-founder and CEO of Solana Labs, which launched the Solana blockchain. Previously, he spent more than 10 years building distributed systems and high-performance operating systems, Qualcomm, Mesosphere, Dropbox. Everyone at this point knows Solana. Then we've got Goon, who just came on stage. He's the co-founder and CEO of Avax, which launched the Avalanche blockchain. He is an associate professor at Cornell University, co-director of IC3, very renowned researcher for his contributions in distributed systems, secure operating systems, and he was the original discoverer of selfish mining. One of the folks who I've learned a great deal from over my career as an investor and a technologist. And then we have Ilya. Ilya is the co-founder and CTO of the Near protocol. He was originally at MemSQL in Google. He worked on Google Search and TensorFlow. He has a background as a competitive programmer and an ICPC finalist. Each of these three founders are extremely technical and very respected leaders in the world of blockchain development. And each of them launched a layer one blockchain that has become a top 20 cryptocurrency by market cap. But each of them takes a different approach in how their blockchains achieve the scale that they do. And so I want to thank all three of you for coming on today, and we're going to have a really fascinating discussion. Naval, do you want to give some background for, I think that there are probably a lot of folks on here who are not super familiar with the landscape and what's gone on in the last few years.
Yeah, we sort of have a general purpose audience here, so I think we're going to keep it fairly high level. We're not going to get into, lots and lots of details about exactly how each blockchain, competes with the others. But To set the stage, first of all, nothing here is investment advice. Don't run out and buy any tokens. These things are very technically sophisticated. These markets are highly manipulated. You should not be buying and selling tokens unless you absolutely know what you're doing and do it for a living. One of the things I love about this space, given how technical it is that the representatives that we have up here, the CEOs and founders of the companies or the projects, are also themselves often the programmers and the designers and the architects who built the first versions. And that's unlike the old Web 1 and Web 2 world or the classic software technology world, where often you have a suit who's talking and the actual person doing the work is in the back room. So people here aren't necessarily the most articulate, although they are articulate, but they're not trained to be articulate. They're sort of just hopefully more authentic, and they're builders. Now the space has evolved a lot. Those of you who got in originally with Bitcoin, remember that breakthrough was that we can have this shared database that we can all operate on trustlessly, where as long as most of the network is honest, we can verify the transactions ourselves. We don't need a central authority to keep track of our money. And we can liberate money from governments or fiat or corporations or centralized organizations. And that was a huge breakthrough. And then Ethereum came along with the idea that, hey, we can extend this to all kinds of computing, not just to money. And ETH really found its application in DeFi. And in the so-called DeFi summer, you had a lot of Wall Street capabilities and more getting built on top of the Ethereum blockchain. But the Ethereum blockchain slowed down a lot, and we've seen Ethereum struggling with scaling issues, because essentially what blockchains do is they auction off block space, and block space is computing power on this giant shared network computer that can make credible commitments to all of its participants. And Ethereum ran out of space, the gas fees went up, and it created an opportunity for new scaling approaches to come out. And so what we have here are probably the top three layer one blockchains, sort of by momentum, adoption, technology, tooling. There are other good ones too. I'm not saying we got everybody, but we've got three of the ones that everyone has their eyes on today, and are picking up the slack from Ethereum as Ethereum kind of tries to figure out both sharding and sharding is just breaking the blockchain and the network into pieces, and each piece kind of processes separate things. And then layer two, where basically like in the classic networking stack or classic computing stack, a lot of computing tends to be hierarchical. You have your cell phone, but your cell phone connects to a server, and that server might connect to might have a caching layer somewhere in there, might connect to AWS, etc. And so different layers of the stack do different activities. And so that offloads the local client, which in this case would be your cell phone, from having to do all the work. So similarly, Ethereum is looking at a layered approach, and they're using these things called rollups and layer twos for scaling. But in the meantime, Solana, Avalanche, Near have come up and are offering very different scaling solutions. So I'm going to turn it over to our three. Maybe I'll start with Anatoly at Solana, because I think you're sort of just going down the leaderboard by market cap. What I would and what I would ask you, Anatoly, is would you mind just giving us a high level, very simple description of how Solana works, and what trade-offs you're making? Because I think we don't necessarily believe in free lunches here. Vitalik and his team are not stupid. They're very smart people. They work very hard. And so you're making different assumptions and different and have a different architecture, but it comes with different trade-offs. So if you could also just focus on the trade-offs that you're explicitly making, what you're good at, what you're not so good at. And yeah, give us a high-level overview of Solana, please, if you don't mind.
Yeah, so Solana is a smart contract platform, and it's one that doesn't do any sharding or layer twos. And that's because the design goal that it kind of set out to achieve was this idea of, blockchain and NASDAQ speed. That was literally the tagline at our seed level slide deck. And the goal there is to kind of guarantee information symmetry around the world. If you imagine this building in Manhattan where NYSE servers exist, and you want to trade there, they'll actually give you a cable that's the exact same length as everyone else's to guarantee that when you send data, it doesn't arrive faster than anyone else's. And when you receive it, you have guarantees that you kind of receive it at the same time and that you're observing the same state as everyone else. And, in theory, with a lot of blood, sweat, and tears, Solana could provide this as a service on just hardware, and it's limited only by the speed of light. So basically information traveling through speed of light through fiber. But that is good enough because news travels at speed of light through fiber. So kind of our big dream horizon kind of end state for Solana is that it's actually competitive to something like NYSE or NASDAQ at providing information symmetry for price discovery for marketplaces, but doing so at a global level. And the entry, the cost to entry to participate in this network is just some hardware. So and this kind of gets right into the thing that we're not good at. So a lot of my Twitter debates with folks on Ethereum is about the cost of hardware or cost to participate in the Solana network. So from my perspective, Solana is the cheapest possible way to implement this thing. So it's the cheapest possible set of hardware. But because this network also does settlement, like every other BFD system, it also runs smart contracts. There's cheaper ways to implement those use cases. But if you actually want to guarantee that when you send a bit and it's globally replicated to all the machines in the world that could possibly subscribe for that bit, and there's some real-time guarantees on that, I don't think you can do it any cheaper than that, because you still have to send all this data, send all these messages, get confirmations. And that's where, true cost of hardware really kind of gets you.
Yeah, thanks for that. So, I mean, if I were to summarize kind of what you're saying, you say you don't do sharding, you don't do layer two, you keep things in sync in a very tight synchronized network, and you do have higher hardware requirements, which is probably the main criticism of Solana.
Much higher.
Yes, much higher. You're operating a smaller number of validators, but they're very high performance validators, and you can scale according to Moore's law or some approximation like that.
Number of validators is not limited in the sense that you can add more validators. It's just the hardware requirements for them are higher. So when you look at
as long as someone can hit your hardware requirement, they're welcome to join as a validator.
You look at something like ETH1 or ETH2, they're both around 4,000 to 5,000 nodes. Solana's at 2,500.
So you have 2,500 validator nodes that are running at full performance and equally passing off in the network. Okay, that's interesting. That's a lot more than I thought I'd read.
Yeah. So when you look at something like ETH2, they define validator as an ETH2 process, but most nodes deploy like 50 validators on a single machine. So when you actually analyze the Ethereum 2 network, despite having 300,000 validators or whatever, there's only 5,000 physical machines. And those physical machines are what counts at the end of the day. Because
so you have 2,500 machines operated by 2,500 different entities, or are some of them operated by the same entity?
Depends. So some of the RPC servers, so this is where proof of work, right, is the one true test for Sybil resistance. You got to burn energy to participate in the network. So that's hard to do. The RPC nodes, a lot of those, a bunch of the Ethereum nodes just simply there to provide data availability, to serve requests. A lot of those are run by fleets, by different companies. So it's hard to say how much go where.
Got it. Well, I don't want to get too much into this digression. Let's give Emin a chance to introduce Avalanche and talk about the trade-offs that he's making and where he thinks it's strong and where he might be not pursuing the market as much.
Sure. So at a very high level, there are a couple of things that distinguish Avalanche from the systems that are out there that people might be familiar with. First and foremost, our vision is different.
I think you're really close to your mic.
Okay.
Did you want to step back slightly?
Is this better?
Maybe slightly better? Go ahead and keep going. Sorry, I didn't mean to stop you in your tracks. You still there?
You might be switching mics or something like that.
Oh, I see.
Why don't we let Ilya go ahead, and then we'll come back to Gun, and maybe he'll try a different mic or something. And it was actually not too bad for me. So even if Gun, you want to go back to your original solution, that would be fine. Ilya, why don't you go ahead and talk about Near for a bit, and we'll come back to Gun.
For sure, yeah. So I guess we are the opposite of Solana. We're doing sharding. And at the high level, kind of our vision in general is way beyond just settlement layer, but really in the computational layer, meaning we want to have kind of all of the applications and all of the kind of normal world apps, social networks, food delivery, etc., to be running in the Web3 world, right? In a world where people own and be able to participate in the governance of these protocols and apps that they own kind of share of this. They can own the data and not give it away to big corporations. And so to do that, kind of we believe in billions of users, which means no single machine can ever handle that. And so kind of as we know from all of the Web2 companies, the solution to go beyond and actually start handling millions of users is to shard, and meaning parallelize the processing and parallelize the storage and parallelize the compute. And so that's kind of what Near is built on a basis of. And there's a lot of complicated technical problems to solve, like data availability and things like that. But that's what we're solving underneath. And then on top, importantly, we trying to make it look and feel like it is a Web2 as well, which means that we allowing people to build in languages like TypeScript, languages like Rust. There's more languages that are coming for developers and as well as for users. We're building the UX by modifying a lot how actually the interaction with blockchain works. So people can just log in with Near and start using apps like they were using them with logging with Facebook or Google.
And so what are the downsides of the sharded approach that you guys are taking?
So one major downside, which is definitely the kind of a big difference from Ethereum and Solana, Ethereum 1 and Solana, is that the processing of different applications is happening in parallel and asynchronously, meaning that if one app calls another one, this happens at a slightly different time. Versus in Ethereum, everything happens within one so-called transaction. And so if any kind of, there's no other operations that can execute between one app calling another on Ethereum. And also if something fails, then everything rolls back. Versus on Near, the interaction between apps is asynchronous, meaning that there are other things that can happen on the network. And there's no kind of automatic rollback that happens if something fails, which means you need to program things a little bit differently, but it also opens up some other opportunities, like running MapReduce, like running a job that hits a lot of applications and then collects the results from them and things like that.
Great, thank you. Emin, I think we've got you on board. Let's give it a shot.
Yeah, let's give it another shot. The application crashed on me for some reason. So I was saying that Avalanche distinguishes itself in a couple of different fundamental ways from the other blockchains out there. First and foremost, we have a different vision. Our vision is not like Bitcoin to try to unseat the dominance of the dollar. Our vision, like Ethereum, is not to build a computer in the sky. Our vision, our goal of the entire system is to digitize all things. So we want to build a system that enables us to convert into blockchain form all sources of value out there, every single thing on any balance sheet, everything anybody might ever want to trade across the globe. We want to build a system that can accommodate this. And so at the technical level, the first and foremost big differentiator is that Avalanche uses a brand new novel protocol called the Avalanche Consensus Protocol. This is completely separate and different from everything that came before it. All of the hundreds of academic protocols that you see before, all of the other proof of stake protocols that you see, they are all doing something that's, not all maybe, but most of them are doing signature accrual. And Avalanche is using something very, very different. It's a probabilistic technique. It's bringing into the proof of stake space some of the insights that Satoshi had about the strength of probabilistic protocols. And as a result, it's achieving finality that's incredibly fast. It's finalizing and making immutable transactions in less than a second, in around 740 milliseconds these days. So the second big differentiator for Avalanche is the fact that it's not a monolithic system. It's not a single system that is designed to accommodate all. We all know that that's not possible. It's just very hard, both performance-wise and also technical infrastructure and legal infrastructure-wise. What Avalanche allows you to do is it allows anybody to be able to create subnets, wherein each and every one of those subnets could run a custom virtual machine. So all of these subnets are powered by the same super fast consensus protocol, but they have their own rule set, or they can have their own custom rule set. So we can spin up, for example, an Ethereum virtual machine, which we did, and we call it the C chain. And a lot of people think the C chain is the totality of Avalanche. It's not. Anybody else could spin up another EVM on top of us. Anybody else could spin up an EVM or any other thing, actually, that's designed for the US. You can create legally compliant networks. So those two big differentiators set us aside from the other systems out there. Now, in terms of downsides, nothing comes for free. There's always some trade-off. The protocol itself is incredibly fast, but it's a new protocol. So we're experimenting with it. We're making fundamental changes with it, and we probably need to do all sorts of adjustments to it. It's not engineered as well as some of these protocols out there that have nothing but engineering going for them. This one has science going for it, but it hasn't had the engineering hammer applied equally well. So that's both a challenge and a sort of an opportunity. If we do it right, we can speed it up even further from where it is. But it also means that we probably have to make a bunch of engineering adjustments. Some of the parameters we set are probably wrong and need to be adjusted. So people have to come into the system knowing that that's going to happen. And so that's the downside of brand new tech from the cutting edge of development.
So if I can maybe summarize the three different approaches that each of these layer ones is taking. So Solana is trying to be extremely high performance and basically put everything into a single high performance machine and run everything all together at a scale that, as Anatoly put it, could try to challenge something like NYSE. Avalanche is taking a totally different approach to consensus, and it's taking this multi-blockchain approach where you can run any different kind of virtual machine on top of a parallel blockchain that operates alongside the other ones under Avalanche consensus. Whereas Near, what they're doing is sharding, meaning that they have multiple blockchains that are of the same type that all talk to each other natively, that scale through asynchrony and in a distributed way, as opposed to by trying to keep everything on the same shard. So the elephant in the room here, which Gun got to in his last answer, is the EVM.
Actually, before we get into the EVM, which I agree is the next point we should talk about, I'm going to try and summarize this even more simply, right? Because I think there's a lot of total newbies in the audience.
Go for it.
This is going to be completely unfair, so I'm going to manage to offend all three of our guests at the same time. I think Solana, at a very high level, it's almost like the big block approach brought into smart contract blockchains. We're going to use, big honking machines and just ram it through, and we're great engineers and it's practical and it works right now. Gun is saying we're going to take the best science and learning out of academia, and we're actually going to try and implement it. And I have to admit, subnets confuse the hell out of me. And I've known Gun for a while, so I do want to have him get into that and explain it in some more detail at some point. And Near seems to me like the ETH2 roadmap actually implemented. Like, let's follow a lot of the same principles and approaches, but let's actually ship the code. Maybe, and to be fair to ETH, it's because you're brand new. You don't necessarily have the technical debt. You have more of an organized team of really high quality programmers who are marching to a single rhythm, and you just don't have all these existing deployed nodes and a proof of work consensus system and all these other things that kind of get in the way. So that's sort of how I think about the three different ones. The big block approach brought to smart contract blockchains, and that's not to belittle it, because I know big block didn't work out in Bitcoin land, but that doesn't mean it's an invalid approach. Bringing the latest and greatest science and actually implementing ETH2 roadmap. But yeah, let's get into EVM, although I think we have to get Gun back.
Definitely offended.
Yeah,
I'm okay with that.
I'm going to guess that, you got some mixed responses there. Let me try to get Gun back on stage, but I'm going to go ahead and set up the question. So EVM is the elephant in the room. Gun mentioned it in one of his answers, and I think most people here probably don't know what the EVM is. So very briefly, the EVM stands for the Ethereum Virtual Machine. Basically, it's a low-level programming language that Ethereum uses, and that is the way in which almost everything that was built in crypto up until about 2020 was written on top of the EVM. So it's kind of the lingua franca of DeFi, of blockchain applications. And if you want to get a crypto interface or crypto community or crypto developers easily building on top of your platform, you should support the EVM, despite all of its warts and it being completely badly designed. It's kind of like JavaScript. It was kind of developed in a fever dream with very little consideration of how this thing was going to scale or how it was going to perform, but we're stuck with it. And so, like it or not, the EVM is the most used infrastructure for building blockchains. So Avalanche has gone the deepest on the EVM. They have this thing called the C chain, which is a complete EVM compatible blockchain. Near has a shard that's dedicated to an EVM contract called Aurora. Solana, as I think Anatoly mentioned, is probably the least EVM oriented of the three, although they do have a team that's slated to launch a virtualized EVM called Neon. So I want to ask each of you, how do you think about the EVM? What is your approach to it? Are we stuck with it? Are we going to move past it? How do you deal with the specter of the EVM?
So we, this was something that we thought about like in depth and with a lot of fear as we were building Solana. We never had more than 18 months of runway, and never felt like we had enough resources to go build full EVM compatibility. So it's never really on the table, and it was not something we prioritized because it's not the fastest, most succinct, cheapest virtual machine you could run. And the core proposition that we were trying to build was, well, imagine like, NASDAQ for everybody. Anybody could plug in a box. They're trading at the same speed as jump trading, and it's open to everybody in the world. And it's, just all you have to do is get some organized sand somewhere. So EVM was not the key differentiator there, and it was never something that we thought would make or break this thing. So we basically didn't prioritize it, and it ended up being in retrospect, like the best decision. And because we got to build a really core, strong community around Rust. Rust is, one of the world's most popular languages, I think voted #1 by GitHub developers. And my intuition as an engineer was that engineers are supposed to learn a new stack every 2 years. It's just kind of part of life. So why would EVM be a blocker for growth, right? If you have something good. So it just never seemed like a strong requirement. And I think as the space matures and grows, because EVM is not a front-end language, it doesn't have that distribution stickiness like JavaScript does, or that Objective-C, the worst, maybe one of the worst design languages ever, has still through Apple. So it may just kind of fade, that's my kind of prognosis, is it's a language that was the only language that you could write smart contracts in and, raise hundreds of millions of dollars. But that's rapidly becoming not true.
Goon, what about for Avalanche? Hey, Goon, you're muted. All right, maybe he's having more tech troubles. Ilya, do you want to take the Near response?
Sure, yeah. So I would say, like, when we were originally starting, right, we tried to, like, literally we're trying to build on Ethereum and kind of, learning Solidity and figuring out all the tooling and doing all the things that, as you need to do as an engineer. And coming from, building DevX for TensorFlow, building tons of stuff on Python, building tons of stuff in C++, it was like a very painful experience in 2018. And so back then, kind of part of our offering and mission was like, how do we make a developer experience that, a regular engineer can pick up and build something in, first 5 minutes and get to an app, first day, and ideally launch something first week, like in production. And so we chose to kind of underneath use WebAssembly. We chose to support pretty much compilation of TypeScript to WebAssembly as well, as a way to onboard all the developers. Now, over time, kind of especially in 2020, the growth of kind of usage, and I would say the metric, the weird metric of amount of money per line of code, which is really weird for any engineer, but it kind of what it is in the Ethereum world, have grown so much. And what that meant is because every single line of code contains a potential bug. And so this small files of 500-600 lines of code, which maintain billions of dollars right now, they are pretty much as proven to not have bugs as it's humanly possibly be, right? Or they have bugs and then somebody steals all this money, which we've seen. But because of this, it gave like such a jolt and boost to the EVM kind of ecosystem that it became clear that there needs to be something in Near to support it. And because we believe in developer experience, and if developer want it, we need to support it. Hence, kind of we work with Aurora team to start this project. And so now we have an Aurora, which actually is just a smart contract that runs on Near. That is an EVM, Ethereum virtual machine, running on top of Near infrastructure. And so this also showcases just the power of WebAssembly, right? The team there took a off-the-shelf EVM code, wrapped it around into a smart contract logic and shipped it. And obviously it's a lot harder than I just described, but kind of high level, Near just allows you to take existing code and just run it and enable developers to really build applications that are way more complex than kind of what you can do in EVM. But then EVM is where a lot of these financial operations are going to continue happening just because of kind of momentum of this money per line of code.
By the way, I've just been kind of looking at the audience, and we have quite a distinguished group of people in the audience, including some developers of some of the most interesting apps out there. So I'm just curious if you also want to weave in your high-level 1 or 2 line pitch to the developers. And developers are a savvy audience, right? They're not going to just go with, yeah, we're the best chain, come on over, we do everything better. So I almost wonder if you can also even talk about what kind of developer you're targeting. So feel free to start adding that in. Because if I'm a developer and I'm building an NFT app marketplace versus a gaming site versus a DeFi app, I'm probably going to be attracted to different chains for different reasons. So it would just be interesting to hear alongside what kind of developer is best suited for your chain.
Sure. I think I dropped out and came back in, but I didn't get a chance to put in my 2 cents on the EVM issue. And I heard 2 different takes, both of which sounded like they were sort of like unwilling entrants into the EVM game. And we're different. We saw the power of the EVM early on. We love the EVM. There are many, many, many reasons to critique it. There is so much to say against it. If I were to design it from scratch, I would not have made any of the low-level decisions that were made in that virtual machine. But it's here. And there is a vibrant community. And that community has been trained how to write Solidity programs. And often the techies kind of start overlooking the importance of the ecosystem. The funnels that bring in developers to any system are there, and they're very entrenched, and they're very difficult to change. I know this because I was a professor, and I know what we taught to people when they said, hey, I want to learn how to write smart contracts. The only option out there was Solidity, and that's what the communities formed around. So, and I came from an Ethereum background, and I wanted to get all my friends to be able to use the system, provide something to them that they would like, and also allow them to do exciting things at a much faster, much higher speed, and also customize it and so forth. So I wanted to tap into that existing ecosystem, and this is essential. It was wonderful for us in the sense that it allowed us to bootstrap ourselves very, very. The EVM implementation in Avalanche took about 3 weeks. We decided about 4 weeks before launch, hey, let's add the C chain, and we just did it. It's that easy to start a new subnet on Avalanche. And as I said, I would totally redesign it if I could, but I can't. It's just what it is. And don't forget that there is a lot of other infrastructure out there. For example, auditors. Suppose you're in the business of writing a smart contract. You will have to get that audited. In this day and age, there's no excuse for not getting it audited. And so if you're going to do that, you're going to have to go to somebody who knows how to audit that stuff. And if you are using a one-off thing that you invented, or if you're using something that for which there is no smart contract savvy developer auditors, then you're going to find it very difficult to deploy secure stuff on that chain. So that is something that we tapped into, and I'm really, really happy about that decision. And so I think, Naval, you asked about why people should use Avalanche.
Well, that right there is a strong differentiator, right? Your wholehearted embrace of the EVM
Well,
and all the tooling and all the auditing and all the ecosystem that goes around it.
Okay. Well, I'll stop there. I can go on for a long time on that. Open-ended question you had, so I'll let other people speak.
Well, I want to build on that because I remember when Naval and I are investors, and we spoke to all three of you guys back in 2017 when you guys were just the very beginning of your journeys in building a blockchain. And back then, there used to be this term, Ethereum killer. And that was the way that almost all these blockchains were pitched, is that, oh, okay, Ethereum sucks, it's failing, 2017, it's not the right architecture to build a modern blockchain. Now, today, we don't use the term Ethereum killer very much. And my question is, what do you think the role is of Ethereum in a world where your blockchain is successful in its goals?
So
And related, is this winner take all, or are we going to see lots and lots of blockchains coexisting for a long time? Because so far, it seems to me that back in the early Bitcoin days, there were a couple of coins like Mastercoin, Namecoin that actually died out. But once we got smart contract blockchains working, and once we kind of had more robust markets, it seems like new blockchains just don't die as long as they have some small community somewhere. They seem to survive. And now we have things like bridging and EVM compatibility and so on. So it just seems like the switching costs are lower than ever, and it seems hard to kill a blockchain. So are we headed to a world where all the layer blockchains can flourish and win, or is it still going to consolidate back down to one or two because of, let's say, network effects around composability or usage or tooling or what have you?
So let me jump into this one. The term Ethereum killer was coined by the marketing division of a company that likes Ethereum very much. So it venerates Ethereum, and so they love painting other people as Ethereum killers. I've said from the get-go that the Avalanche system, the Avalanche community is incredibly friendly to Ethereum. Last thing we would target is to take market share away from what's happening on ETH. And to that end, we work really, really hard, especially compared to, say, layer twos, which are almost all trying to take away load that's currently on Ethereum and not really developing their own assets. We work very hard to develop new assets for our chain. And the future is multi-chain. The future is one of bridges. And to that end, we developed I think the world's fastest and cheapest bridge to use that uses an entirely different technology for minimizing trust. And I think we're going to see this year be a war of bridges where value will float to whichever blockchain provides the best functionality for the cheapest. And in the future, ETH is not going to die. ETH is not going anywhere. It's fantastic. It does what it does. Its challenges are all internal. Will they be able to do something that changes the system? And will they be able to deliver? That's the real question. There will be huge growth. And the chains that come out ahead are those that are going to be able to absorb that growth. And with our subnet, with our ability to spin out new chains, with our high performance consensus protocol, we believe that we can absorb that hundreds of trillions of dollars of assets that are going to be going into blockchain form.
Anatoly, what's your take?
I think because these are backend systems, I think it's kind of hard to actually have a winner take all. Because like an end user, like as you see now using MetaMask, can easily use something like Avalanche. And at some point, the end users are not going to care like where their orders are routed. And in a lot of ways, block space is fungible. A user that wants to do a transaction has some understanding where their assets lie, but even that I think can melt away. With regards to like Ethereum or the ETH killer thing, Solana is just such a weird, different design. I never quite understood why anybody would would try to label us as an ETH killer. Like we're design-wise and not even being EVM compatible. It was just folks like to paint a fight, right? And and that's I guess fine, right? Like I think in some respects it's good to battle like on the intellectual level because it kind of hones what you're doing, like what use cases are you building and targeting. So for Solana and Ethereum coexisting, I kind of think of where Ethereum is going as more settlement, and where Solana is going is execution. And execution is where potentially there's use cases that really do need full global composability, that sharding or logical sharding and rollups breaks markets, right? It creates price arbitrage and all these other effects that you may really want to avoid for a lot of marketplaces. That may not be true for all of them, but I think it's definitely obvious that there's a lot of marketplaces that don't want that at all. So how that plays out in terms of what use cases actually are the killer ones that onboard, a million, hundreds of millions of people. That's a tough question. If I knew that already, it would be I'd be building it right now.
Yeah, you're basically saying that there's some applications that just aren't parallelizable. And it's funny because I'm probably a little older than most of you, but I remember in the early days of computing, or early in desktop computing, it was all serial processing, right? The heavy parallelization pipelines that came up with GPUs and some of the more modern multi-core CPUs came much later. And for a long time, it was thought that we just weren't going to be able to parallelize apps on a practical basis. Like it was definitely more academic, or it was in very specific context. But nowadays, I think the assumption is the opposite, that everything can be parallelized. But you're saying, no, there are some apps that hit the entire global state of, say, a market. And so they're just inherently serial in nature. For those, you just need a very fast system, a single-threaded fast system.
If you have two marketplaces, right, and it's different rollups for the same asset, you get arbitrage between those prices. And that may be okay for a lot of assets, but maybe that's not maybe there are market makers and liquidity providers that actually want to have a single kind of one giant exchange, right, with a long tail that has everything atomically in one place, right, to trade. So that's a very kind of convoluted example, but like state, right, separation of this information into separate buckets means that you have to now resynchronize it. And that if that's financial information, that resynchronization has a cost, a real dollar cost. It depends, it really depends. Do users care about that? And is the dollar cost high enough to where like it's maybe worthwhile paying, or is it just easier if an alternative exists to just throw everything to one bucket if it's good enough and fast enough? And because these are backend systems, it's really hard to figure out, are these the most important things to an end consumer that's actually looking at a DeFi, NFT game, and doesn't really even think about, is there a blockchain behind it? So those are 5-10 year questions that are, I think, way too hard to answer right now. But kind of fundamentally, I think it's pretty obvious that people want things to be cheaper and faster and with less speed bumps. If you have to tell your users, well, we've split your game into two, and now whenever you want to cross from DeFi town A to DeFi town B, you have to go move assets around, pay fees, wait. Those experiences may be detrimental, and that game developer is like, well, screw this, I'm just going to go build on Solana.
Yeah, I think at least today we're in a world where the APIs are essentially, we're using bridges to pass tokens around between different apps, and then the app does its own logic on its own chain, on whatever chain it's on within the app. But I don't know the answer to this. I'm genuinely curious. I'm wondering if we're going to evolve apps in such a way that the APIs are going to get much more complex. And then it ends up something like a Windows OS or a Mac OS where you have to be bug for bug compatible. And even if you're like 95% compatible, that's not good enough. And so then there is a network effect that starts accruing to the chain, which has the largest number of composable apps. Basically, if the bridges don't operate perfectly, and if the bridges can't carry all of the information needed, or if there's information in state or some kind of value that is outside of just the pure token, and if that bridge model is imperfect, then I think we will start seeing a network effect consolidating around whichever chain has the largest number of composable apps. We're
Well,
not there
actually,
today.
there is already example for this. It's NFTs. So NFTs, like on Near, for example, have royalties embedded into the standard itself. So if you're trading it on the marketplace, royalties automatically go to whoever created it. But if you move that NFT to another chain via a bridge, like let's imagine you move that NFT to Ethereum now and you want to trade it on OpenSea, because OpenSea doesn't support royalties in the same format, and if it did, like the royalty needs to be routed back to an account on another chain, that already breaks up kind of the whole protocol. And this is actually a pretty simple example, but you know, as you're building games and other more complex interactions, as that breaks down. So even though bridges are really important, they have very kind of limited set of functionality that would allow people to transport things. And then there's a bunch of chains you cannot actually build a proper secure bridge because they don't have full security, light client stuff. That is, or as and even beyond that, ideally, full security will be a full verifiable client, which is almost impossible. So I think like yes, bridges are powerful. They'll allow us to do a lot of things, but they will not kind of remove completely the distinctions between blockchains and kind of specific details that these blockchains have.
So it's really interesting. I don't know if people remember, but back in the old days, there were multiple competing DOSes. MS-DOS was, of course, Microsoft DOS, but there were other DOSes that were actually more popular, and MS-DOS kind of won out by being bundled with the IBM PC as a default. But there were competing DOSes for quite a while, and it was really when Windows came along, and Windows was very complicated, and it became very difficult to now write a program that would run on Windows as well as on, God, I've even forgotten its competitors. That's how powerful the network effect was, but it definitely had window management competitors that were running on top of other people's DOSes. So as the space gets more complicated, there will be sort of this embrace and extend of functionality, some deliberate, some kind of just accidental. You want to add new functionality, you rush out, you add on your own chain. You don't care if it can get bridged or not. And so this is a very interesting question. If we live in a heavily bridged world, then there's going to be a lot more competition for block space. You'll be able to shift your apps around. But if the bridges don't completely carry all the different potential states across, and clever developers will come up with new and new states, then there is going to be a network effect, or probably will be, where the number of apps and the composability across the apps will lead to a dominant chain.
I think the question really comes down to what are people going to be using blockchains for? So at the end of the day, if, in the vision of Anatoly, if blockchains are going to be used for, very, very rich and thick financial markets, or if they're going to be used for gaming, which require extremely low levels of latency, and you need everything to be composed on a single chain, then something like Solana is the right architecture for something like that. But if, on the other hand, we're going to have, tens of millions, hundreds of millions of people, all of whom could not fit their transactions onto a single logical machine, then something like what Goon and Ilya are working on with with Avalanche and Near is a necessity, because a system that gets too big must get distributed into multiple pieces. And so right now, what we see on Ethereum is that we've got DeFi, we've got NFTs. Those seem to be the two big things that are working. How do you guys see the future of where smart contracts and crypto is going?
Sorry, you muted out, Hasid.
No,
I think Jack has his thumb on this
clearly.
room, and he's
He's not happy about what we're
customer
talking
support.
about here.
Yeah,
We should have put
Twitter
Bitcoin in the
customer
name, and I
support.
think we
It
would have
really
done
did
a lot
arrive.
better.
Yeah, so just mention
Exactly.
Bitcoin every couple minutes.
Yeah. So I think you guys got the thrust of the
Everyone
question.
switch on your red laser eyes, please.
And totally.
So,
Oh, sorry. Go ahead.
So I was just going to say, responding to the question about how we see blockchains being utilized and in what areas. So if you have a blockchain that is supposed to be one size fits all, if you have a single chain that's supposed to handle everything, then I think you're going to find that whoever has the capacity to pay the highest fees will dominate your chain. That's as simple as that. So the DeFi guys, if your system actually supports DeFi, its transaction sizes are big enough, it's actually versatile enough for DeFi, then you will find that the DeFi folks are paying the highest fees, and they will crowd out everybody else. There'll be no room for anybody else to trade NFTs because that you have to pay $100 for a DeFi transaction, and that's what you're competing, and that's what you're auctioning the space away from. So I think that architecture does not lend itself to multi-use. And I think we're going to find that people who are betting on these monolithic architectures are going to find themselves cornered.
Well, that
just like
sounds
Ethereum.
logical, but in reality, there's a lot of NFT activity in Solana, right?
You don't, you have X amount of capacity, arbitrage and DeFi needs some percentage of that. They don't need to bid for more than that percent of the capacity. And priority in the block is a separate market from just getting bandwidth. There's no need for like the kind of auction that you see in a mempool. That's not a good implementation. So we don't have to copy that from Ethereum.
Can I dumb that down a bit? You're basically saying that, if I understand what you're saying that the DeFi apps, they might bid for priority, but they don't need all the space. So they might
Correct.
go first. They might be the ones to get through if there's a hiccup and the network slows down, because they're more mission critical and they can pay a lot more, but there's enough space for the NFTs and the games, at least as envisioned today. But I guess where Gun and Ilya are sort of betting is that no, we're going to have millions of assets and tens of millions of transactions, and it can grow faster than Moore's law, and we need to make room for all of these, including these Web3 apps and this multi-chain future. So maybe a single layer architecture will just get overwhelmed. That seems to be the differing viewpoints.
Yeah, exactly right, Naval. I think it's a folly to try to generalize from today. We're so early. So the usage patterns you see today are, they are what they are. But extrapolate 5 years out, and you're going to find that whoever is paying the highest fees is crowding everyone else out. And that is what you see on Ethereum, by the way, right? So the high fee paying DeFi transactions have crowded out all of the uses of Ethereum for.
I also would mention that Anatoly's point that like if you have games or markets, that the only way to do it is like split them in two and then you have arbitrage. It's kind of similar to the point that we cannot paralyze this process, because if we split it in two, then there's lots of locks and it slows down. But there's always a way to paralyze in some other way. So for example, if it's a market, you could paralyze it by spreading the orders across and actually having the orders matching happening on like in a parallel way, and then you actually have a fully sharded DEX that actually scales as well with number of shards and with number of processes.
Ilya, how does that doesn't actually make sense, does it? So a DEX is the kind of thing where you really need to match against the best order, and if you're going to match against the best order, you got to get routed globally.
But so you need to match against best order, but matching doesn't always need to happen on specifically this smart contract. So you can be like, what you want to make sure that assets are there and that these orders were stored and then that matching happened. Like the insurance that this is the best match can be happening not by the single smart contract.
You have a single price time queue, right? At the end of the day, there's a top of this book that says I'm the best price for this particular pair. That can only exist at one spot. And
hold on, I feel like we're bike shedding a bit.
Yeah,
So I'm gonna.
okay.
We got 5 minutes left, so I'm gonna cut the
Yeah, I'm lost,
the Dex
so
conversation. So
yeah.
no worries, no worries.
I'd
Okay,
also like to cover, even though I don't know if it was on our agenda, but I'd love to chat briefly about decentralization because I think, like, channeling my inner ETH maxi, which I'm not, but suppose I was, I would basically say, well, none of these are really that decentralized. You know, your Gini coefficient is pretty high. You know, maybe Emin has a plan to decentralize more, but right now it doesn't have enough nodes running. The system requirements in Solana are absurd. And you guys are only getting away with all of this because we're in an environment that doesn't care about decentralization because they aren't cracking down yet. You don't have feds busting down doors, shutting down blockchains, arresting developers, which I'm not arguing will happen in the US, but you know, could start happening in other countries. You know, some of you are CEOs of companies or heads of foundations. If we had to pull all the developers off the job, then the development would sort of fall apart. Whereas, you know, ETH has foundation and a decentralized developer base. So, you know, one very loud and large argument is that you're not really decentralized. So I would really throw the ball in your court. How decentralized are you? Could you survive tomorrow? If would your protocol survive tomorrow if most of your main validators who could be identified and were operating in large controlled jurisdictions were shut down? If some of your validators started getting arrested, computers started getting turned off, if nation state attackers started putting in fake messages and fake machines, and then if you and the developers living in the United States or, you know, in the West were forbidden from working, like, how decentralized are you really? Who can survive that level of an assault?
So I would argue that Bitcoin would not survive a US banning it.
That's a big statement.
I think the answer here is
absolutely not.
It's still early. It's still early,
yeah.
and
Napster didn't. People like wanted music, right? Like, as soon as if the if the United States has enough reason to ban it, they would. But because they don't, it's not actually, I think, a threat to the US at all. It's a threat to everybody else who's not in the free world, I would say, more so than anybody who is in the free world. There's no reason for that to happen. And I think core decentralization is actually about the nodes. If you destroy every copy of the state in the ledger, you destroy the coin. You can't prove who owns what, it's gone. And that physical representation of this thing is the most important piece of decentralization. So this is where I think Bitcoin's pretty far ahead. I think they're like at 14,000 nodes or something like that. Solana's at 2,500, something around there. And there's no reason why Solana couldn't get there or pass it. And
does someone want to take the other side of that, though? Do you really have 2,500 independent? I know you can't because of the civil problem. You can't tell if they're independent or not. But are there really 2,500 nodes that are distributed independently operating or roughly independently operating? Does someone want to take the other side of that? I'm not trying to create controversy. I just want to fact check, and I don't have the knowledge.
There is about close to 1,400 validators. Most of those, I believe, are independent because there's no point to run two. And there's about 1,200 RPC nodes. And I would say those are probably not independent, but each one of those is still a valid full copy of the state.
So we don't even count RPC nodes. I think, so let me just first agree with Anatoly. I think he's so right when he says that Bitcoin is not the standard here. The number of mining pools that determine the Bitcoin blockchain matters very much. And lots of people have studied this. There are so many academic studies on the mining landscape in Bitcoin. Very few of them colluding together, just a couple of 3 to 4 of them could start rewriting the blockchain. They would never do that. I'm not suggesting this is a real threat, but if you look at the theoretical limits of Bitcoin's decentralization, it's actually very, very small. Proof of work has this kind of winner-takes-all kind of dynamic where the mining pools get really, really large typically, and very small numbers of them become very successful because they have low cost of electricity.
But at that point, wouldn't end users leave the mining pools, or the developers would propose a protocol upgrade that strips those mining pools, out, or bricks hardware, things of that nature?
You can't do that at Bitcoin. No, proof of work doesn't work that way because the hardware.
Yeah,
Yeah, I
we
mean, yeah, you would have to change the consensus algorithm probably, but I guess there would be maybe a user revolt where the users would
So,
start moving their mining power out of the pools. I mean, these are pools, and the people underneath, as long as they're committed to the original Bitcoin vision, wouldn't stand for a pool that's rewriting the blockchain.
the
Yeah,
pools can.
let's not discuss. Let's not discuss. I think there are a whole set of things that can be said here. We've seen large pools attack Bitcoin in the past. I think those of you who were around in 14, 15 will remember.
Whoops. Looks
But
like we
I
lost
think
you.
like we should go back to kind of what we're trying to solve here, and what we're trying to solve here is, this network's running. They're not affected by any central party. The community is able to govern and continue evolving them, versus specifics of how many pools need to collude, etc. And obviously, we want to have economical guarantees and practical guarantees that these networks are correct and continue working. And generally, proof of stake is way better in this sense than proof of work, for not having huge rollbacks, not having like bribing attacks on miners, right? How Binance did it and things like that. So I think like proof of stake is addressing some of these problems already, and like all of us are continuously growing the number of nodes and kind of replication and kind of also the governance, decentralized governance of the systems.
So indeed,
Well,
so
the choice of proof of
if I may
stake.
finish my thought from before, I think before Jack booted me out. The point that I was
Poltergeist name check.
the thing that's important to note here is to reverse the narratives a little bit. That a lot of people say things like Bitcoin is the most decentralized. No, it has quantifiable decentralization. It's worth looking at where these bottlenecks lie, where the Gini coefficients are, and one of the most important metrics that I want everybody to at least take away from is the number of nodes that participate in decisions. If you're just an onlooker, then you're a bystander. You're not part of the network. You're not part of the protocol. You have no voice. And protocols differ very much in how many nodes actually participate in any given decision. And that metric is key. On that metric, Avalanche it has the capacity to have millions participate in every decision. And it's the only chain that can say this because of its probabilistic decision making underneath. So I'm really proud of that. And we could accommodate millions and millions of block producers. I'm looking forward to that future.
All right. Well, we are past time, so I'm going to try to very, very briefly summarize. Look, each of the three of you
But
take
wait,
a totally
I don't know
different
if we
approach.
have to end unless these guys have to go. I'm happy to keep going. So it's up to
I have to
people.
go. I
Oh, you do?
tell you,
Okay,
I
all
have to go.
right.
So
Damn it, Nasib.
I know.
We got the three
I am
most
the host.
important
So
people in like layer one
look,
alternative
I'm sure
Bitcoin.
many of the folks who are here also have to go.
Jesus.
So to
Cancel the meeting.
summarize, very, very briefly, look, each of you are taking different approaches to scaling. And I think the one note that you all agreed on is that we're really early, and there's a lot that we still don't know, and there's a lot of game left to be played. So we've yet to see how layer 2s are going to play into all this. We've yet to see what Ethereum is going to evolve into. Is it going to stick around, or is it going to be eclipsed by what the three of you are doing? I want to give each of you 1 minute to tell the folks in the audience who are not as familiar with your blockchains, what is the one thing they should go on your blockchain and do? If I was the Ethereum representative, I'd say go mint some DAI, go buy something on OpenSea, go borrow on Compound. What should they go do on your blockchain to understand what you're about? Anatoly, why don't you go first?
Install Phantom, go play around with Mango Markets and Magic Eden.
Good.
So simply take your coins on any other chain, bridge them over to Avalanche, and go play with any of the DeFi applications we have hanging off of our ecosystem page.
Similarly, bridge your coin through Rainbow Bridge or other bridges and try it out on Aurora. 0 fees. 1 second finality.
Brilliant. All right, Naval, you want to give the last word?
No, I mean, I think we have fairly different approaches here towards solving the smart contract scaling problem. What I'm impressed by is just the sheer amount of brain power that's being thrown at it. We haven't even talked about, for example, the layer 2 scaling solutions, the so-called roll-ups on top of ETH, but there's incredible work being done there as well. And of course, those roll-ups are not captive to ETH. Like if things are working well, they would shift to Avalanche or they would shift to Near. I don't think Solana really supports layer 2s yet, but maybe they will in the future. But so there's a lot of work being done here in scaling. I guess a mental model to think about it is that the Bitcoin model, which is appropriate for securing money, is that everybody gets to verify what's going on. Everybody runs a massive, we run a massive network of computers. It runs at the speed of the slowest computer. We want the largest number of computers cross-checking it because it's so important. And so everyone can fire up their laptop and in theory, eventually sync as a Bitcoin node without permission and without having to rely on any trusted third party and verify that transaction. But what you're having is you have this network of 14,000 computers, but they're all running like one slow computer. There was some professor at Berkeley recently who wrote an article talking about how blockchains don't scale, and he showed how his Raspberry Pi could be faster than the Bitcoin network. And the whole thing completely missed the point. It's like the point is not to be performant, the point is to be trustworthy and secure. And so we throw away all the computing power in exchange for the security. And then the ETH model is sort of trying to do that for computation, but that doesn't scale because general purpose computation is expensive. So now you kind of come down to, well, how do we scale? The Solana approach is, okay, well, we're not going to do this in everyone's laptop. We're going to get some high quality performant machines. We'll still try to have enough of them that is sufficiently decentralized. It'll keep the programming model simple, and we'll run everyone through one queue. And I think that most of the Solana people are background as hardware engineers, and they did some clever things around time locks and synchronization that you can look up. And they said, we're just going to have one very, very fast moving set of supercomputers you can rely on. It keeps the programming model simple, and it allows us to scale right now. And Amin and Ilya are taking, I would say, more computer science approaches in between, saying, well, we can split the network into pieces. We can create subnets, we can create shards, we can do layer 2s and rollups eventually on top. We can utilize every technique that ETH has thought of and implement, and every technique that's sitting out there in the literature that's any good. And we can create subnets and shards and fragments and pieces of the network, and we can dynamically rearrange the network as needed. So you can choose the level of security that you want. You can choose the level of decentralization that you want that's appropriate for your app. I don't have to protect my gaming NFT from the nation state, but perhaps I have to protect my DeFi application from a country that has strict capital controls and doesn't want me moving money around. So I think that we're going to see a thousand flowers bloom here. We're going to see a lot of different approaches, a lot of different blockchains. Again, these are back-end technologies. These are meant for developers. These are not investable or necessarily even usable for the average person. But over time, we're going to converge to the right answer. And the right answer may be multiple answers, different ones for different use cases. Grateful to have had you all here. Learned a lot. I hope you did as well. And we'll look forward to doing more of these. Thank you, everybody.
Thank you.
Thank you very much,
everybody. Take care, all.